Okay, so we're going to do 2.2 absolute value functions. And we're going to start with the definition. Parent function y equals absolute value of x. When I write absolute value, I try to draw the bars slightly bigger than the line so I don't confuse them for a number 1. Okay? The definition is a piecewise equation, right? That's why we do piecewise first. The definition of y equals absolute value of x is this. And sometimes it's written as 3 parts and sometimes it's written as 2 parts. I'm going to do it as 2 parts. The first part is negative x. Domain x less than 0. The second part, x, positive 1 slope. Domain x more than 0. I left off an equals for momentarily. We're going to make a table of values that goes with both the parent function y equals absolute value of x and the piecewise graph. These two things are equal. They are exactly the same. Okay? So we're going to plug in the points from -2 all the way to +2. And then we're going to graph them. Okay, so when I plug in -2, I get +2. It doesn't matter which one we plug into, they are exactly the same. The absolute value of -1 is +1. And then we're going to take these 5 points and we're just going to put them on the graph. And I'm actually going to put a few more points on the graph. Now notice that in the piecewise definition, those are lines, they are linear, and so I can actually count that slope to get a few extra points on the graph. Okay, we have 2 new characteristics to add. One of them is the vertex, which is this corner point right there. Vertex. The vertex appears to be in the center of the graph. It looks like it's in the middle. Okay? It's in the center. It also appears to be the minimum point. Now I'm going to put min/max, and I'm just going to underline minimum because in this particular graph, the vertex is the minimum. And I'm just going to write the coordinates of the vertex. Right? We should be able to label our characteristics. We're just adding some vocab here. Vertex, it's in the center, it's a minimum or possibly a maximum. We have one more characteristic to add. Axis of symmetry. I'm going to abbreviate this AOS, axis of symmetry. And I'm just going to draw it on the graph because it's more of a visual. Characteristics are very visual. It's this vertical line down the center of the graph where the symmetry occurs. Notice that the left half and the right half are exactly the same. You have symmetry over that red dotted line. And it's x equals 0, and I'll put axis of symmetry. It's a vertical line. Vertical line. And I'm going to say through the vertex, because the vertex is the center. That's where the symmetry occurs. Through the vertex. This is your parent graph. You need to memorize this graph. You need to know what it looks like, okay? You need to be able to tell me those vocab words or those characteristics. This is your new parent function. The reason you have to memorize it is because we graph by transformations in Algebra 2. Up, down, right, left, stretch, reflect. Same words you did a couple weeks ago. This shape will always go with the absolute value parent function. I guess I should name it absolute value. That's the name of this parent function. It will always look like this. It will always have a negative slope, then a vertex, then a positive slope for the parent. Okay? Transformation form. Because we graph by transformations, we have to use the letters A, H, and K, just like we did in the previous lesson. Okay, so our transformation form, I'm using capital A, lowercase looks like a 9. Yes?
For the definition, for the absolute value,
Oh, good point.
You
Okay.
don't close it, do you?
Good point. I forgot to say that. Notice how this is the shared endpoint. That means that I'm only actually going to include it in one of the places, not both. Yes. The 3-part definition, they put the vertex separate on a middle line. There's no reason to do it as 3 parts. 2 parts is sufficient. But the equals could go in either, not both.
Is that an addition?
Where?
Transformation form?
This is an addition, yes. Yeah.
Why were you said like y equals and then the brackets? Then is there a line in front of the x?
Oh, I was just like,
It's one.
it's a 1 slope.
It's not like that's the value.
No, it's just a 1 slope.
But the chapter writer?
No, we're gonna talk about that number, so I wanted to make sure that you know it's a 1 right here, because it's gonna change in a minute. Okay, so we have our transformation form. We need to, 1, how do I know this is an absolute value? Because I'm using absolute value bars. That's how I know this is connected to the absolute value parent function. Now, all you have to do is watch. Okay, I'm going to put the graph up in Desmos, and we're going to change the A, H, and K, and just see what happens. Bye. You can see it already. Okay, so here is my absolute value transformation form. I'm going to add my sliders for A. It automatically places the value at 1. And so I'm going to take my H and my K, I'm going to move them back to 0, and we're just going to look at the graph. Okay. There's my parent function. Do you see the +1 slope on the right side, the -1 slope on the left side of the vertex? Okay. We're going to change A first. I'm going to change it to 2. How does that change the parent graph? Idris? Changes the slope. I'm going to say slope in quotes because the absolute value graph has a -2 slope on the left of the vertex and a +2 slope. So this time let's just drag the A value. It gets narrower, wider. Oh, what happened? Oh, okay. Did the vertex move? No. Did the negative A value reflect over the x-axis? Same words that you already learned. In this particular case, it's easier to say the graph opens down because the parent always opens up. And so with the negative, the graph opens down. Look at the slope though. Now the positive slope is to the left of the vertex and the negative slope is to the right of the vertex. Okay, so let's put our A value back to 1. Okay, parent function. Let's move H and K. H. Back to the origin. K. If I pick values for H and K, can you graph it? If you have values for A, H, and K, can you put the vertex in the right place? Can you count the lines, the slopes in the right way? This is right 2, up 3, slope in quotes of 2, because the slope is negative and then it's positive. Okay, let's try it. Let's write down what A, H, and K are doing to my parent graph. A, I'm going to say open up or down because the parent is always up. And so opening up is a positive A value. Opening down is a negative A value. Can you still say the word reflect? Yes, you can. Reflect over X. Okay, but I want to say one more thing that is specific to this parent function. I have 2 types of slopes. I have a negative slope and then a positive slope. If your A value is positive, what comes first? The negative slope or the positive slope? Negative. Okay, I'm going to say quotes. It's not really slope, guys, because it's negative then positive. So it's negative then a positive slope if the graph is opening up. Then if my A value is negative or the graph is opening down, it's a positive then negative slope. It's important because this is a lot of information. It's kind of easy and quick to draw a graph, but you have to be able to do more things with it. Okay, what does my H do? Right or left? Opposite, as a reminder, opposite from what I see. K, up or down? Same. Now my HK happen to be connected to the vertex. Right? My transformation is connected to the vertex. My axis of symmetry is connected to the vertex. It's the vertical line through the vertex. See that X coordinate? That's where your axis of symmetry comes from. Okay. Let's graph. Y equals 2. Absolute value. Okay, there's our equation. I need to say what A, H, and K is going to do to the parent. Now, this graph, this parent graph, is memorized. I'm not going to draw it for you. You're going to get a blank graph and you're going to have to draw it. So I'm going to sketch it very, very lightly in pencil because that's the general shape of the graph that I need to draw. Okay, how do I know it's absolute value? Because you see absolute value bars in the equation. That's how you know what shape it is. A. I'm just going to transformations. Here we go. Opens up. Because it's a positive 2. And I'm going to say slope is opening up. Okay, so what comes first? Negative or positive slope? Okay, negative 2, negative 2, then positive 2 slope. My slope is changing in the absolute value graph. Okay, next transformation. Right 3, down 4. Oh, that tells me about the vertex, right? The transformation, the translation, tells me about the vertex. Okay, let's put it on the graph. Right 3, down 4. There's my vertex. This is just like a visual of the vocab, right? I'm just putting it on the graph so you can see it. Positive 2 slope. But it's going to be negative 2, and then it switches to positive 2. I'm going left to right. Means I need to count a negative 2 slope. Remember, slopes are from left to right, so it's falling. It's falling to the vertex, and then it's rising after the vertex. There's your graph. That's it. But I'm just labeling my new characteristics so that you can see them. Axis of symmetry, x equals 3 through the vertex. It's a vertical line, that's x equals. Okay, there we go. Negative 2/3. Absolute value of x plus 2 plus 3. Transformation. And then I'm going to add a domain and range characteristic, right? All previous information is fair game, guys. Can't forget it. It just pops up a little bit here and there. Open, down, down. Positive slope, then negative slope. So slope, 2/3. So it's going to be slope. It's going to be positive 2/3, then negative 2/3. It switches at my vertex. left 2, up 3, left 2, left 2, up 3. Put it on the graph. Okay. Opening down, which means that it's a positive slope first, then it's a negative slope. Okay. Who can give me the domain or the range? I'll take either. Review characteristic, think about it. Interval notation. Do you have it? Yes. Negative infinity to positive. It's continuous. I don't lift my pencil all the way from the left, all the way to the right. Okay, range. Range is a little trickier. Yes. Can you tell me why you chose to say negative infinity first before you said 3? Because it's a smaller number. It's like more negative. It's left to right on the number line or bottom to top. Hard bracket. Guys, you only do open brackets if you actually see a big open circle on the graph. Okay. Oh, I guess I could label my axis of symmetry. Dot, dot, x equals -2 for the axis of symmetry. Okay. We have, hopefully, 2 questions left. That's my goal. 2 questions. Okay. All real numbers. Write as a piecewise equation. Okay. That's the question. I didn't give you a graph on purpose. All I want you to do, put the vertex in the correct quadrant, okay? Don't put this to scale. You need to get comfortable with graphs that are not scaled. Left 2, down 5. Okay, so my vertex, not to scale. All I'm going to do is label the point. Is my graph opening up or down? Up. Okay. Just up. Do not count this. Just draw it up. You need to be comfortable taking away specifics from a graph and just the general idea, because that's how you do things quickly. Which side of this thing has the negative slope? Okay, so I'm just going to jot, boom, -2 on the left side, because the left side of this graph has the negative slope, and the right side of this graph has the positive slope. Did I label any y-intercepts? No, don't. Don't. You don't need them. Can you turn this into a 2-part piecewise equation? Now I'm going to give you the domain to help you. X less than or equal to -2. More than. Okay, notice that I only included the -2 once because it's a shared endpoint. All that information I just told you on the first page about first the negative slope happens and then the positive slope happens. Can you use point slope form to do this? Because notice that I do not have any intercepts labeled, so don't use them. First, the negative slope happens. Okay, so really I'm going to just put my y1 over here. I can do it. X plus 2 minus 5. How do I know this is linear? Guys, my absolute value bars turn to parentheses. That's how I know this is linear, not absolute value. Okay, how do I know that the left side, you have to have corresponding slope and domain. The left of the vertex had the negative slope. The right of my vertex has a positive slope. Notice that there's not a lot changing. You are basically pairing up the correct slope with the correct domain. Because the shared vertex, the shared point doesn't change. I have 4 examples. I have 3 minutes. This is it. Do you need to multiply it out? Not really. Okay, yeah, could you? Because you're multiplying by an integer? Yes, but you don't really have to. Okay, last example. Sketch. Sketch means I don't need it to scale. Okay, that's what sketch means. Sketch the inequality. Y more than 3. Absolute value of x minus 4. See how much bigger those bars are? You don't think it's a 31x. It's 3. Absolute value of x minus 4. Okay, so we're just going to put not to scale. Means you're only going to label like 1 or 2 points in about the right place. I'm going to put some review information up here just to get you thinking the right way. Solid versus dotted. And I'm going to call them borders because it's not really a line. It's absolute value. Solid or dotted borders. How do you know which? Shading above or below. Okay. Vertex. Right here at 0, -4. It's just down 4. It's opening up. Now, I'm going to label my point here because this is a sketch and I'm pretty sure I can count a 3 slope and put the next point on the graph. Okay. But do I make it solid line or dotted line? Yeah. Solid is for the equals. Dotted is for the not equal. Not including the border. Did you know not including the border really means that you have open circles? That's really what it means. But it's hard to draw open circles on a graph, so they always did closed points and then dotted lines. It's really just open points. It's a set of open points. So you just draw them as dotted lines. It's just a set of open points. Okay, how do I shade? Greater than, less than. This says greater than.